everyone. The stream is starting now. I will say hello to everyone. The first thing what we always have to test if is the audio right. So I would like to have someone in the live chat to confirm that the audio is okay, that everyone can hear us loud and clear, that we have no echo and so on. Und ja, dann werde ich das selber nochmal auf Deutsch sagen. Also ich begrüße erstmal alle. Die ersten paar Sekunden machen wir wieder einen Soundcheck. Heute ist sogar das Besondere, dass wir erstmal den Anfang in Deutsch machen und dann immer mal ein bisschen auf Englisch springen. Und die Gäste werden wir auf Englisch vorstellen. Hallo, der Chat ist da. Und ich weiß, der 2. Juni ist es nicht. Entschuldigt gleich erstmal den Fehler. Wir haben natürlich the 3rd June today and not the 2nd June, which is on the presentation. Also wir haben heute den 3. Juni. Das gleich als Entschuldigung. Und dann,
I have changed it today.
Ja, ich habe es nochmal geändert. Aber die restlichen Punkte sind natürlich gleich. Ich mache mal noch den Ralf, tue ich mal noch anpinnen, damit ihr mich auch seht. Ich hoffe, ihr könnt mich jetzt gleich sehen. Noch nicht. Aber die Präsentation ist schon da. Pin-Video. Genau, also auch nochmal von meiner Seite. Die Agenda und die Community. Die Community kennt ihr. Wir haben noch Slack. Im Slack ist es ziemlich ruhig. Da wäre mal interessant zu wissen, ob wir eventuell auf Matrix, also Riot oder sowas wechseln sollen. Ansonsten bleibt es bei Slack. Ihr habt die QR-Codes, ihr könnt dazukommen, wenn ihr Informationen braucht, auch für die, die vielleicht jetzt neu dazugekommen sind. Wir sind aus Sachsen. So we are from Saxony, Germany usually, and now we're doing the online meetups, and that's the pleasure because we get speakers from abroad, namely today from US, I guess, and for the speakers, more information later on. Right now, I will introduce the team. Das kennen wahrscheinlich schon die meisten, die bei uns sind. Wir sind 6 Leute im Orga-Team. Heute dazugekommen ist der Thor Alexander. So today we have guests also from another meetup group. This is Thor Alexander. Und den möchte ich nochmal kurz vorstellen. Also der hat ein Blockchain-Institut, macht selber Meetups in Stuttgart und der kann bestimmt nochmal kurz gerne Hallo sagen. Sag nochmal Hallo.
Hallo. Hallo, sind sicherlich auch ein paar Leute von mir im Meetup mit da, heute ein bisschen anderes Format und schauen wir mal, ob wir das in der Zukunft vielleicht auch ein bisschen etablieren können, dass wir Gemeinschaftsveranstaltungen machen zwischen uns und euch. Und wir kennen uns ja auch schon länger, Arno und Ralf. Und ja, dann übergebe ich das Wort wieder zurück an dich, Arno.
Ja, also für Kooperationen sind wir immer offen. Und ich glaube, das sieht man bei uns auch ganz gut an der Agenda. Wir haben nämlich heute einen 60-Minuten-Vortrag. Letzten Monat hatten wir Joshi da, der hat uns auch ein interessantes Thema vorgestellt. Wir haben sogar einen richtigen interaktiven, sage ich mal, Live-Workshop eigentlich gehabt. Auch so knapp eine Stunde, knapp drüber. Und das würden wir heute halt auch machen. Wie ihr das gewohnt seid, as usual, you get the 4 weeks of latest news from the blockchain space before that presentation, and that I will do with Ralf together. We will do it in German, so wir werden das in Deutsch machen, weil wir das letzte Mal festgestellt haben, dass es vielleicht besser ist, einfach um die Inhalte besser rüberzubringen. Und da würde ich jetzt einfach mal anfangen. So I will start the news. I personally start with a big Bitcoin picture, so that's why I have some funny and some maybe more serious news. Ich habe unten zum Beispiel Bitcoin und SpaceX wetten auf die Zukunft der Menschheit. Das soll mal so ein bisschen mehr der Joke eigentlich sein, wie man schöne Headlines verpacken kann. Wer den Artikel gelesen hat, der kann ja mal ein Feedback geben, ob er wirklich lesenswert war. Ich habe mich beim Titel schon begeistern können. Und dann habe ich in der Mitte dazu, weil es so lustig ist, noch so das Bitcoin Sweet Corn Cream Style Dosensymbol mal mitgebracht. Also wer das kennt, bei Bitcoin gibt es ja so ein lustiges Spiel mit Corn. Ja, einfach nochmal da eine Erinnerung. Und dann ein bisschen ernstere News. Und zwar gibt es bei Twitter den Bitcoin Optech. Da sind technische Updates und technische News. Und da gibt es auch jetzt in letzter Zeit auch vom Peter, das ist ein Core-Developer, interessante News zu Taproot. Also das ist, sollte man sich nicht entgehen lassen. Taproot, Schnorrsignaturen ist nochmal heiß geworden. Ist relativ interessant im Moment, weil die Hardware-Wallets natürlich ein Problem eben haben, wenn sich immer die Adressen ändert. Aber technisch gesehen, lest euch das da rein, wenn es euch interessiert. Und dann, ganz wichtig, aktueller Bezug. In der Amerika, habt ihr bestimmt mitbekommen, gibt es gerade ein bisschen Revolten. Und da habe ich einfach nur mal von Bitcoin News einen aktuellen Tweet rausgesucht. Ne? Da gibt es das berühmte Bild, nicht Bomben werfen, sondern Bitcoin nutzen. Und damit würde ich einfach mal in eine andere Region überleiten, und zwar China. Natürlich im Blockchain-Bereich auch sehr wichtig. Da habe ich 2 News. Es gibt irgendwie ein neues Gesetz. Ich habe nicht sehr genau reingelesen, habe es euch aber mal hier mitgebracht mit den Kevin Helms und dem Titel, solltet ihr es selber finden. Auch sehr gerne gesehen, wenn ihr in den Chat dazu irgendwie vielleicht noch Neuigkeiten schreibt. Die lese ich dann, wenn der Ralf dran ist, und kann noch gegebenenfalls einen Nachtrag machen. Und vielleicht links noch das Bild, das sind in 2020 Blockchain-Firmen, die in China sozusagen sich gebildet haben und da irgendwas Tolles machen, wahrscheinlich Smart Contracts programmieren, und da einfach mal aus Interesse halber so ein paar Zahlen. Ne? Also es sind irgendwie 4.000 neue, und das sind ja nur 4 Monate, also es ist gigantisch, ne? was da kommt. Und ja, Ralf, dann bin ich relativ schnell durch. Wird das an dich übergeben?
Ja, gerne. Hallo erstmal nochmal auch an alle. Hello at all. I hope we have a good evening. I will switch back to German. Und ja, Arno, kannst du weitergehen, weil ich sehe nur, dass über YouTube deine Präsentation
Habe
gerade
ich
sind.
gemacht.
Ja, deshalb werde ich das also jetzt noch ein bisschen überbrücken. Wir sind dann zu hören. Und ja, wir bleiben in China. Und die chinesische kommunistische Partei hat aus meiner Sicht den absoluten Kryptolit, das nicht nur in China, sondern aus meiner Sicht weltweit. Die schulen jetzt, also die chinesische Parteischule, die schulen jetzt ihre höchsten Kader alle in Krypto, in Hightech. Und es gibt ein neues Buch, das ist wohl letzte Woche erschienen. Ich versuche ganz krampfhaft, dieses zu bekommen von meinem ehemaligen Masterstudenten Junlin aus China. Und dort ist unter anderem auch beschrieben, wie die sich die CBDC, also die staatlichen digitalen Währungen vorstellen. Die rechnen dort auch mit Libra ab, halten das für kompletten Schund, soweit ich das aus dem Auszug gelesen oder mir habe übersetzen lassen. Und ich bin mal ganz gespannt. Die rechnen dann auch mit dem Good-Dollar-Projekt ab, welches ja letzte Woche veröffentlicht worden ist, aber da kommen wir noch dazu. Also die Kommunistische Partei, auch an ihrem Parteitag, der da letzte Woche war, Arno sagt es ja schon mit dem Gesetz, ganz, ganz weit vorne. Und aus meiner Sicht hat China hier den absoluten Lead. Ja, und dann, Arno, sollten wir zum nächsten gehen?
The US Awaken?
Not yet, but I hope so.
Ja, kommt.
Noch ist es nicht zu sehen, aber ja, ich sagte es ja vorhin schon, die USA scheinen aufgewacht zu sein, nicht nur durch Corona, wo man ja dann überlegt hatte, ob man die $1.200, die dort hätten verteilt werden sollen, ob man die an den über Krypto, also über eine Zentralbankwährung, eine digitale verteilt. Aber dann hat man festgestellt, so einfach geht das nicht, so schnell geht das nicht, weil die eigentlichen Überweisungssysteme des Fiat-Geld alle noch in COBOL geschrieben sind und man das nicht so schnell umprogrammieren, anpassungsprogrammieren kann. Und die COBOL-Programmierer offensichtlich, die das gemacht haben in den 50ern und 60ern, alle gestorben sind oder nicht mehr aktiv. Das ist ähnlich wie das Apollo-Raumfahrtprogramm, wo ja auch einige der Ergebnisse heute nicht mehr nutzbar sind. Ja. Man hätte so gerne eine Atlas-V-Rakete nochmal gebaut, aber die Baupläne waren einfach weg und damit auch die Software und alles andere. Archivproblem. Ja, das Good-Dollar-Projekt oder das Digital-Dollar-Projekt ist, das Papier ist gemacht worden von Accenture. Und nicht nur die USA vertrauen auf dieses Accenture-Papier, auch die schwedische Reichsbank, die ja auch an Piloten fährt und auch, glaube ich, auch Kanada, aber das kann man in dem alles nachlesen. digitaldollarproject.org ohne Leerzeichen, ganz interessant, aber weit hinter dem, was die Chinesen jetzt schon realisiert haben. Ja, das nächste ist dann auch, wo ich sage, naja, diejenigen, die nach China kommen, denke ich, wird Facebook sein mit Libra. Ich glaube trotzdem, dass China 18 bis 24 Monate Vorsprung hat. Ach, da hast du was rausgenommen, Arno, oder hast du die
Nein, ich habe
Reihenfolge?
alles drin, ist nur die Reihenfolge. Ich bin jetzt auf Libra Goes, ja? Willst du Libra haben?
Ja, wenn du hast, also will sagen, Libra ist, wenn sie nicht gestoppt werden, könnte vielleicht noch ein bisschen was aufholen. Aber Facebook hat sozusagen sein Wallet, was ja Calibra hieß, seine Wallet-Application umbenannt in Novi. Und da kann man auch, jeder kann da mal probieren, ob er sich jetzt schon ein Novi-Wallet, naja, ich sag mal, sein eigen nennt oder runterlädt. Aber scheint auch interessant zu sein. Und dadurch, das hat man ja im letzten Meetup schon, dadurch, dass Libra jetzt ja seinen Coin komplett in verschiedene, 4 oder 5 verschiedene Währungen gebackt hat, 50% im US-Dollar, der dann dadurch eine weltweit weitere oder weiterhin die Führungsposition bekäme oder hätte. Aber wie gesagt, es ist ja jetzt hier der Kampf der Giganten oder der Systeme, der sich hier abzeichnet. Das ist genauso schlimm wie ehemals der Kalte Krieg zwischen China und USA. Es geht um die Vorherrschaft, sage ich mal, der digitalen Hauptwährung, um die es in Zukunft gehen wird, über die man, glaube ich, sehr viel Einfluss nehmen kann. Und das, was wir jetzt in der Welt derzeit zwischen China und USA sehen, das sind nur Vorgeplänkel dessen, was aus meiner Sicht im Finanzmarkt noch kommt. Aber es ist ein kalter Krieg, der derzeit auch Handelskrieg genannt wird, aber der Finanzkrieg ist in vollem Gange. Dann auch etwas Neues aus meiner Sicht, was sich am Enterprise Ethereum Alliance Horizont abzeichnet. Das ist das sogenannte Baselining-Protokoll. Das ist seit Januar eine Open-Source-Initiative, gestartet von Ernst & Young, Unibreit, ein Startup aus Deutschland, ist dort auch Taskforce-Führer in der Enterprise Ethereum Alliance. Und Microsoft ist auch mit dabei. Und da geht es darum, dass das Enterprise-Protokoll eine Technologie ist, um Backend-Systeme, klassische Backend-Systeme über das Mainnet von Ethereum zu verbinden unter der Nutzung von Zero-Knowledge-Proof Technology. Das bedeutet, alle Daten, die in den Backend-Systemen gehandelt werden, werden nicht Identity-Daten oder sonst was werden nicht übertragen, sondern die Zero-Knowledge-Proof-Technologie hat ja die Eigenschaft, dass ich etwas bestätige, ohne es genau zu wissen, was der eigentliche Inhalt ist. Ich kann es aber trotzdem mathematisch bestätigen. Und so werden Transaktionsverkettungen über das Blockchain Mainnet, das kostet also dann nur Gas, gekoppelt. Und es gibt hier ein wunderbares Video, wo man ein SAP-ERP-System mit Microsoft Dynamics gekoppelt hat. Die nächste Kopplung, die ansteht, ist, dass man diese zwei Systeme noch mit einer dritten Partei koppelt, Salesforce, und es zeichnet sich ein absoluter Run auf das Baseline-Protokoll ab, aus meiner Sicht, wo es darum geht, ich sag mal, einen neuen Industriestandard für die Kopplung von Systemen Blockchain-basiert über das Mainnet zu realisieren. Kann sich jeder angucken. Die Website ist baseline-protocol.org. Ganz interessante Geschichte. Dort laufen dann auch Digital also Identity über. Ja, das nächste wäre dann, Arno, du kannst eins weiterblättern.
Ja, ich habe jetzt Ethereum Classic und Ethereum offen, aber ich habe noch eine Frage mit dem Baselining. Da wäre ja mal Zeit, dass wir einen Sprecher kriegen, oder? Also das klingt ja so spannend. Da müssen wir ja mal einen Fachexperten reinholen für sowas.
Habe ich schon bei Unibreit bei den zwei Gründern von Unibreit angefragt, dass die das mal bei uns vorstellen, ein bisschen intensiver, vielleicht auch hier im Meetup. Unibreit sitzt in NRW, glaube ich, und ganz interessant, hat auch, glaube ich, oder ich weiß es, sehr intensive Beziehungen nach Mittweida zur Volksbank. Da wird wohl einiges auch in den Blockchain-Schaufensterregionen-Projekten durch Unibreit entstehen mit dieser Technologie. Ja, das nächste ist Ethereum Classic und Ethereum, sage ich mal, haben wohl Protokollgleichheit, 100%ige Protokollgleichheit erreicht. Hat mich jetzt ein bisschen überrascht. Die Meldung war ja von gestern oder vorgestern. Ich hatte das überhaupt nicht auf dem Schirm. Die Frage ist für mich, ja, kann man die wieder zusammenführen? Wahrscheinlich technisch wäre das möglich. Ob es natürlich von der Governance her zusammenpassen würde, ne? Weiß nicht. Und
Das
die
wäre
sind ja
eine
damals
ziemliche
bei den,
Herausforderung, die wieder zusammenzuführen. Zumal du ja die geklauten 150 Millionen auf einer Adresse in der einen Blockchain hast, die sich nicht bewegen darfst, und auf der anderen hast du wieder ganz andere Historie.
Was heißt nicht
ja,
bewegen darf?
Herausforderung
Bewegen kann
wäre
man die
es.
schon.
da
Bewegen darf man die schon, ja.
Ja, die
da
andere
ist
Frage wäre natürlich, man könnte natürlich das Ethereum Classic in Ethereum umrechnen.
ja alle Möglichkeiten.
Dann kannst du es einfacher wieder zusammenführen.
Ja, der Auslöser dessen, dass es ja Ethereum Classic gibt, ist ja ein bisschen die DAO gewesen. Ich habe Christoph heute früh vergessen zu fragen, was er davon hält, ob man das überhaupt wieder zusammenführen könnte.
Aber er
ich
hat es ja
glaube,
verschuldet.
der verschuldet, das kann ich so nicht sagen. Er war der Auslöser dafür.
Na, er hat den Code programmiert, hat er mir erzählt.
Ja, das weiß ich.
Aber als Programmierer muss ich sagen, gibt keinen Code, der fehlerfrei ist. Und der Fehler wäre mir garantiert auch passiert.
Deshalb würde ich in keinem Fall von Verschulden sprechen, sondern das war zu diesem Zeitpunkt eine intelligente Maßnahme, um die eingelagerten Werte zu verdoppeln. Ja, ist ja beim Bitcoin ist das ja auch mal passiert, ne? Als man einfach mal gesagt hat, oh, ich mache eine neue Chain, ich mache einen Fork. Dann hat man noch nicht entschieden, die anderen Bitcoins da totzulegen, sondern die waren dann einfach da. Oder haben weiter.
Warte mal kurz, Ralf, was ich noch sagen wollte. Du hast gerade mit dem Hyphen-Protokoll erzählt, wenn die 100%ige Protokollgleichheit haben. Das heißt, du kannst das Zeug natürlich auch auf Ethereum Classic nutzen. Die Blockchain ist weniger voll. Da ist quasi Transaktionsgebühren sind günstiger dadurch. Die Frage ist natürlich, wie es mit der Zuverlässigkeit, mit der Performance aussieht im Netzwerk, aber zumindest wäre das natürlich eine Variante, dass man es nicht über Ethereum macht, sondern über Ethereum Classic.
Ja, oder noch eine neue Variante, Idee, aber da bin ich jetzt nicht tief genug drin, wäre das als Hybrid-Chain über Polkadot oder Substrate, hat man das letzte Mal hier vielleicht als Parachain zu integrieren, weiß nicht, ob das geht, oder irgendwie zu verbinden, aber egal. Gut, ja, und dann, was ich mich heute auch gewundert habe, es gibt ja jetzt so viele DeFis, die Bitcoin sozusagen, wo der Bitcoin in DeFi auf Ethereum eingepackt ist als ERC20-Token. Und da ist die Frage, was soll denn das? Geld im Geld? Also erstaunt mich, aber das geht ab wie Nachbarskatze, wie man auf dem Diagramm sieht, ja. Und scheint ein wachsender Markt zu sein.
Ja, der Vorteil ist, du kannst halt über Dexen kannst du relativ einfach von Bitcoin in irgendeine Ethereum-Token oder Ethereum switchen. Und du hast ja zum Beispiel den DAI im Ethereum, der jetzt nicht, der ein arithmetischer Stablecoin ist und der ganz anders funktioniert als diesen IOU-Stablecoins. Und ich habe bei mir in der Gruppe den Sergej, der die Unicorn Exchange oder sowas, hat er mit programmiert, und was die machen ist, das Problem bei den Dexen ist ja, dass die nicht genug Volumen haben. Ja. Und wenn du jetzt zum Beispiel Ethereum in DAI tauschen willst, dann gucken die halt nach, über welche Decks die welche Volumina schicken, und die haben sogar noch einen Mechanismus mit eingebaut, dass du einen Teil von den Transaktionsgebühren von dem Gas wieder zurückkriegst. So, und wenn ich jetzt natürlich so über solche Geschichten spekuliere, wo ich unterm Radar bleibe und alles komplett im Ethereum-Netzwerk mache, dann kann ich natürlich schön zwischen Bitcoin und irgendwelchen anderen Token oder über Ethereum hin und her switchen und mir meine Guthaben nach oben traden oder halt nach unten, wenn ich es unintelligent mache. Also von daher denke ich, sehe ich da schon beim Trading her nutzen. Die andere Sache ist mit dem Geld, also Luftgeld, in ein anderes Luftgeld einsperren. Das ist wie wie Zentralbankgeld, also Euro-Banknoten, der Bank geben. Dann habe ich ja nur ein Anrecht auf das Zentralbankgeld. Ne?
Ja, aber
Hast du mein Buch gelesen bis dahin?
So, also
ja,
ich will die Diskussion nicht abwürgen, aber ich muss
Wir
daran
haben noch
erinnern,
Programm, ja.
ja,
Ja.
ich muss daran erinnern, wir haben einen straffen Zeitplan und wir haben Zuschauer, die da Wert drauf legen. Wir sind jetzt schon 5 Minuten drüber. So,
Aber warte mal kurz, vielleicht darf ich noch, weil wir jetzt eh gerade beim Geld sind, ich habe bei mir eine Anfrage bekommen, und zwar in meinem Buch Dezentrales Geld habe ich auch mal über Funlai gesprochen. Funlai ist eine chinesische Währung ohne Geld. Das heißt, es ist so ein Leistungskreditsystem. Das heißt, ich leiste irgendwas und habe dann eine Schuld, und diese Schuld kann dann von jemand anders auch wieder aufgerechnet und verrechnet werden. Und ich habe einen bei mir, der im Schwarzwald so ein System bei sich versucht zu etablieren. Und ich finde das eine interessante Methode. Er hat auch mal vorgeschlagen, das bei einem Meetup vorzustellen, weil beim Krypto sind wir ja auch in einer anderen Form von Geld. Und hier haben wir quasi auch ein Leistungssystem oder ein Abrechnungssystem, aber ohne Geld. Und da ist auch die Frage an die Runde, besteht da Interesse, sodass wir das vielleicht auch mal in einem Online-Meetup mit vorstellen können, in irgendeinem künftigen.
Nehmen wir einfach mit an das Ende der heutigen,
Genau.
mit in die Diskussion for the Futures, Themen auf Meetup.
haben wir
Und,
normalerweise immer am Ende in der Agenda. Also es
War länger nicht mehr bei euch,
ist
entschuldige.
kein Problem. Du kannst ja auch die Agenda nicht so richtig sehen, wenn du jetzt im Zoom bist.
Deswegen ja, das ist das
läuft bei
Problem.
mir. Matt and I think we have also another one. Jordan and Mac from Nervos are here. I would like to have some small introduction from you too. I only prepared Matt Quinn with a separate slide for the introduction. But maybe, Matt, you can introduce Jordan as well and explain a little bit about the next 60 minutes and how the presentation is structured before Matt will share the screen, because then we will have his picture also here in the stream. So, Matt,
sure.
Yeah.
Just get started. All right. So I'm Matt. Yeah, Arno, do you have an introduction for me? I'll just do the whole introduction.
No, of course. I just can. I looked like 10 or 20 minutes in Google, of course, and I found your Medium posts, and I was like really surprised by the technical details which you provided in the Medium posts. And then I took the picture, of course, from there. I noticed that you are very long in the space. Also, your Twitter handle is like Bitcoin in the name. So I think you're really attached to the crypto space. So you have different views and now different opinions. So what should I say more? I mean, I
really appreciate it. It's great.
Yeah, I hope we will get very detailed information now about Nervos and maybe also background information about the structure and how you participate and what you are actually doing there, of course.
Sure. So yeah, Jordan and I will be talking about Nervos today. So it's a project that was started in 2018. The idea came from a former Ethereum core dev that believed that sharding was not going to be the proper way of going forward. So the idea was to create a single chain with a layered architecture that could support somebody's audio is that believed that
yeah, you have to
sharding was not going to be the proper way of going forward. Just keep going. The idea was to create
could you turn off the YouTube stream, the audio?
Chain,
and Ralf, you also have to mute yourself, Ralf. Ralf, mute your audio, please.
Sharding was not going to be the proper way of going forward. The idea was to create waiting for the audio to stop echoing.
Ralf, audio, please. Mute yourself. And Matt, you turned off the audio in the YouTube stream, which you're maybe watching?
I don't have the YouTube stream on.
Okay, so now I think it's fine. So let's do it again. And I hope everyone else is silent, please.
All right, great. Yeah, I really appreciate the introduction of me, Arno, and yeah, happy to be here with Jordan introducing Nervos. So the original idea, I think, came out of a former Ethereum core dev who worked on sharding and felt that moving to this multi-chain architecture was going to change kind of the fundamental designs of blockchains that we're used to in such a way that it required building another option. So Nervos is a single chain designed to support layer 2 solutions, and for that to be the way we scale forward. The project did a private funding round early 2018 and raised, I think, $27 million, and then a public sale late last year that raised, I think, $73 million. The mainnet was launched in November of last year, so it's been up for about 6 months now. Yeah, I guess, is there anything else I should add about Nervos before I get to introducing Jordan?
I think in the presentation we will also get more information, and so far I did not get any questions in the live chat in YouTube, but I will say it in German. Ihr könnt auch Fragen in Deutsch stellen. Ich würde die dann versuchen zu übersetzen, so that we can ask, like the guys are asking German questions, and I will try to translate them, because maybe someone is more confident in putting German questions in the chat.
Sure, great. Okay, all right. With that, I will turn it over to Jordan, who does developer relations at the Nervos Foundation. He's been in the Bitcoin space for a long time, and chatted on IRC with core devs, and got it, dabbled in Ethereum and built some projects. And yeah, with that, I will turn it over to him to begin the presentation.
Great, thanks, Matt. Yeah, so I'm Jordan. I'm a senior software engineer here at Nervos, and I've been in blockchain since 2011. And today we're going to be talking about Nervos. I'm going to start with a quick overview here. So let me just share my screen. And where is the, there it is, the share button. Okay. Okay, is my screen up there? Can we see that okay?
Yep, of course, it's there.
Great. Okay, so Nervos, a multi-layer blockchain network. Today we're going to be covering a couple different topics. The first is the CKB VM, which is a RISC-V virtual machine that's used to execute smart contracts on Nervos. Then we're going to go into the cell model, which is the underlying data structure that powers Nervos. Then we'll cover NC Max, which is the consensus algorithm that's used on the Nervos Layer 1 blockchain. And lastly, we'll cover some of the network architecture and how it enables light clients on Nervos. So a quick primer here, Nervos in 30 minutes or less. Nervos is a proof of work, multi-asset, store of value, general purpose blockchain designed for limitless innovation. That confusing phrase you'll find on our marketing materials. What it actually means is Nervos is a smart contract platform, kind of like Ethereum, but it uses a very, very different architecture underneath, which has a lot of differences from Ethereum. So Nervos uses a multi-layer approach to achieve scalability without sacrifice. It does this by using 3 different points here. The first is flexibility. The virtual machine that runs Ethereum, or that runs smart contracts, is a full computer. You can actually take the ELF binary that the virtual machine executes your smart contracts, and you can run it on a Linux computer. There's absolutely no difference. And this offers a tremendous amount of flexibility, enabling functionality that may not be possible at all on other platforms. It's also designed to be very secure. Nervos has taken a zero compromise approach since the very beginning. The layer 1 uses proof of work, a consensus called NC Max, and provides the highest level of security and decentralization. And it incorporates a feature called first-class assets, which we'll go into a little bit later, which may actually help mitigate certain types of smart contract attacks entirely. And it's also designed to be very sustainable. Nervos directly aligns incentives to create long-term sustainable economic sustainable model. The Nervos' native token called the CK byte is directly aligned with state storage. In order to put data onto the blockchain, you must have CK bytes, and 1 CK byte equates to 1 byte of state storage. This makes it very similar to owning real estate. And users that occupy state are responsible for paying the state rent. This perpetually pays miners even after subsidies end. So the CKB VM design goals. CKB VM is the virtual machine that executes smart contracts on Nervos. It was designed for flexibility. Over time, technology is going to change, programming languages are going to change, cryptography is going to change. And the developers of Nervos wanted to design a platform that was both powerful today, but also flexible enough to run for decades into the future. And they wanted it, of course, to be very stable. CKB VM is part of the layer 1 blockchain, and the entire Nervos ecosystem is going to depend on it and be built on top of it. This foundation needs to be rock solid, which means the technology and the standards that are used in this also have to be rock solid as well. And lastly, we needed resource auditing. There needs to be visibility into what the smart contracts are doing and how much resource they're actually using. Ethereum uses gas to track computational resource utilization, and Nervos has a very similar need. So what is RISC-V? RISC-V is a modern instruction set architecture that is built on decades of learning from previous instruction sets, such as 86, which is in most of our computers, and it's designed to power hardware for decades to come. It's an open source standard based on modern principles and transparent governance, which makes it a very good fit for open source software. It's strongly supported by some of the largest and most recognized tech companies in the world. These are companies like Google, Samsung, Sony, Hitachi, NVIDIA, IBM, HP, Alibaba, Western Digital, Seagate, and a whole bunch more. I mean, this is really backed by some giants. And it's stable and mature. Even though you may not have heard of it, it's actually been around since 2010. It's been established. It's fully had it's gone through its growing pains, and it's built for modern hardware development. So the immutability of blockchains is actually a lot like hardware because you can't change it, and it makes it a very natural fit. So the case for RISC-V. So RISC-V allows CKB VM to achieve all of the design goals we mentioned earlier. Flexibility. RISC-V is a hardware instruction set. CKB VM is emulating the lowest level possible, and this gives smart contracts a full computer to execute on. So it's not a limited environment, it's actually a full computer. Stability, the standard is mature and extremely well supported by all major international tech companies. It also has hardware support and is officially supported by many popular compilers like GCC, LLVM, and the Rust compiler. Also on stability, the standard is designed for hardware. Just like with hardware, once you produce it, you can't go back and revise it very easily like you can software. And so this means that they had to take a lot of care into designing the standards here, and that they are basically guaranteeing with their standard that it will always be backwards compatible. And so because immutable blockchains have so many similar qualities, this is a really good fit for that. And then this also works great for resource auditing because CPU cycles at their lowest level can be just counted. And whenever you have something executing, a smart contract executing on CKB VM, it's running essentially on bare metal, and you can just count the raw CPU cycles and you know exactly how much computational resources were used during execution. So why didn't we use WASM? Well, it was considered, but Nervos ultimately decided to go another direction. WASM is a relatively new technology that could introduce some attack surfaces that we're not fully aware yet. I mean, it simply hasn't had time to really stand out there and be battle tested. It's pretty brand new. Code validation is also much more complicated for just-in-time compilation, which is used in WASM. This added complexity could also open up some unknown attack vectors. And WASM is still evolving and still changing. A lot of blockchains are already using modified implementations of the WASM specification today. And so it's possible that they may continue to diverge in the future. It really wasn't an absolute perfect fit for the beginning. And I don't think there's anybody on the team who dislikes WASM. We just believed that there was a better solution. So let's talk about a bit of the flexibility that CKB VM brings. Like I've mentioned a couple times, it is a full computer, not an environment that is limited like WASM. You can do certain things with it, like you can use any type of a crypto primitive. For example, Shor, BLS, ZK Snarks, and ZK Starks. All of these can be done without a hard fork. You can just add a new project to your library, just like any other project, and you're ready to go. You know, there's been quite a few hard forks that have been put out just to address some of these issues on other chains. We simply don't have that because we're operating on a much lower level. You can also use any programming language as long as it can compile to the RISC-V architecture. This means that you can keep using all your favorite IDEs and tooling, and you don't actually have to switch to anything new. I know that for people who use Solidity, there was a lot of pain when in the early days when you had to dump all your editors to start using Solidity, and you don't have to do that because we allow you to compile any of the languages that are supported for RISC-V. You can just continue to use them. So current support, official support, is mainly with C today, but we have Rust and JavaScript that are almost ready, and we have support for more languages coming soon. And then an example of the flexibility here is you can actually run a virtual machine inside of CKB VM if you wanted to. There's actually an experimental project out there that's in development that will allow you to run the Ethereum virtual machine on top of Nervos. So you can really do pretty much anything you want here, including if you really wanted to rerun virtual machines inside of virtual machines on top of CKB VM. Not sure why anybody would want to do that, but if you wanted to, you could. You have complete flexibility. Okay, so now I'm going to go quickly into what the cell model is, because this is a really important concept in Nervos. The cell model defines how data is used within Nervos. And a cell is the most basic structure needed to represent a single piece of data on Nervos. It has three basic components. The first is data. Data can take any form. This could be a smart contract executable or interpreted code like JavaScript, or digital assets like tokens. The second is a lock script. A lock script defines the owner of the cell. This could be a single user or multiple users by including multi-sig functionality. You can actually do some really neat stuff here. A lock script can actually look at an entire transaction and see all the conditions that are present. So you can do conditional locking just depending on what's going on in the transaction. And the third is a TypeScript. A TypeScript is kind of like a smart contract. It contains all the developer-defined rules that a cell must follow. So first-class assets. This is another really important concept regarding security in Nervos. On the Nervos blockchain, digital assets are the property and responsibility of their owner. This means that digital assets are owned by the user, not the smart contract. This is a really subtle difference, but it's pretty important. User authority is paramount. The user has complete authority over the assets that they own. Not even the smart contract owner has the ability to modify assets once they've been given to the user. So if the smart contract owner was crooked and he tried to take back what he had already given you, he can't do that. It's unaffected by a lot of smart contract exploits because of this. Even if a vulnerability exists in the smart contractor, the attacker is locked out of the asset itself. This is again because the contract, it does not own the asset. The user owns the asset, and user authority is always paramount and comes before the smart contract. And lastly, the user is responsible for upkeep. This is important for developers because this gives a clearly defined ownership model, and it also defines who's responsible for the upkeep. The owner of the asset is responsible for the state rent on Nervos. So if you're a developer with hundreds of thousands of users, you're not going to get buried with state rent fees. Every user is responsible for what they use. And usually this isn't much. It's a couple fractions of a penny even. But when you're talking about hundreds of thousands, potentially millions of users, all of a sudden that adds up, and that could make a project a non-viable. But when you spread it out to the users for what they're actually using, it makes a lot more sense. So microstate. Every cell is an independent piece of state. What does this actually mean? It means that the total state of the network is effectively sharded into little pieces called microstate. These pieces can be easily moved between layer 1 and layer 2 without causing any side effects. This makes parallel smart contract execution possible. When a smart contract executes, it only needs to be concerned with the relevant pieces of microstate, not the entire system. This leads to massive scalability improvements. And multiple microstate transformations can also be batched together into a single transaction. This reduces the overhead and fees associated with the transaction processing. So if you're a developer and you do a lot of very similar actions, you can actually just take all of those actions and put them into one big transaction rather than having to do them individually. And all of these make the cell model an ideal fit for development on layer 2. So now I'm going to run through a really basic UDT transaction. This is kind of a complicated example, which I'll try to keep as simple as possible. And if you don't completely get it at this point, that's not really too important. This should just give you a general idea of the difference between the account model, which is used on something like Ethereum, and the cell model, which is used on Nervos. So we're going to go through what a basic UDT transaction looks like. A UDT, by the way, stands for user-defined token. And this is very similar to ERC20 on Ethereum. So when a transaction is first created, you specify your input cells. This is a cell that already exists. So in this case, we're looking at a token here. And I'll show you the token values in just a moment. And the second part of the transaction you need to specify is your output cells. This is going to be the cell that is created and the state of the network once you're actually done with the transition here, the transaction is processed, this is what's going to happen. So let's take a look at what's in each of these cells here. If you look at the input cell, it's owned by Bob. It's of the type star coin, and it contains 10, and that means it has 10 star coins in it. And if you look at the output cell now, it's owned by John. It's of the type star coin as well, and it has 10 in it also. The type are the same and the amount are the same, only the owner is different between the two here. So in this transaction, what we're describing is a transfer of 10 star tokens from Bob to John. So we send this transaction to the network and it begins to execute. First, the input cell is checked to make sure that the creator of the transaction actually owns that and that they have the authority to use it. It was signed properly, so it validates and the cell is unlocked for use. Next, the Starcoin contract, the smart contract, is going to execute. And it's going to validate the entire transaction to make sure that this is conforming to the rules that were set up by the developer. And the main rule that it needs to follow is it's going to look at the output cell and specifically the data value there. And it's going to make sure that the amount of star coins present in the output is equal or less to the input. This makes sure that nobody can cheat and create an unlimited amount of tokens. The amount of coins is the same in both the input and the output, so that validates, and in turn, the smart contract validates. Next, the input cell is consumed, which converts it into a dead cell. This is, if you're familiar at all with the Bitcoin UTXO model, this is very similar to that. You can only use a cell exactly once. This prevents double spends. And the dead cell can no longer be used and is removed from the current blockchain state. And that's it. The transaction confirmed and the tokens have been transferred to the new user.
Jordan, can we ask some questions? Because we had in the live chat already some comments and I would like to use the moment to ask you something. Is this okay?
Yeah, absolutely.
First of all, there was a question about the cell itself. Is this cell kind of, do we have a data structure? Because you said it's kind of data. So does it have some specific format? Is it some binary code? You know, in protocols, you have the header, which indicates, okay, this is the type of cell and so on. Or how can we like picture it more on a technical level, the phrase cell?
Yes. This cell does have a specific data structure. It's a little bit more complicated than what you see on screen right now. It has actually 4 different fields, but only 3 are truly relevant at this point. The data, the lock script, and the type script. There's I can't just describe the exact data structure because it's a little bit too complicated for a general conversation.
Of course.
But it is comprised of mainly these 3 pieces of data here.
And
the important one to really look at is data, because this is defined by the developer, that you can actually put in any data structure you want within the data field. This could be raw binary. This could be, you could do something like JSON if you wanted to, or you can, we support a standard called molecule, which is similar to protocol buffers, where you can load your data into that cell. And then the lock script and the TypeScript are actual, those are the ELF binaries, Linux ELF binaries that we had mentioned earlier. These are full-on programs that execute in a specific order. So both of these here have access to the full transaction. They can read through all the data, or they can read the data that you've specified in your data field. So this is kind of how you manipulate data here. It's by using these scripts that you've written, these executables that are actually able to read into the data that you've defined in any structure.
And the scripts, like currently that we have a list of scripts which are available because of the operations which are possible on the RISC-V, or is the developer able to also extend the list of possible scripts which I can use, for example, in TypeScript?
I'm not 100% sure if I got that. Like when we talk about a script, we're talking about a program, and this is a user-defined.
I mean program code, exactly. So I mean, like,
You're right.
do we have, like, right now we have a binary which Nervos and the developers provide, so you can use it. So you're kind of limited in the current programming code possibilities which you can use, or is it also like open source and I can extend it? Because if you say you are able to put in the data some JSON format, I maybe need my own binary for the JSON data which I put in. So that's...
Yeah, the scripts that we're talking about here are full programs, and those are defined by the user. You can do anything you want to. There's not really any limitation here. It's not 100% correct to say this, but you could just say that a script is a smart contract. It's complete flexibility. You define anything you want, whatever language that you want to use, you can use that as long as it can compile to a RISC-V binary. Then you're able to use that as a script.
And the RISC-V binaries, they are made by the manufacturers of the integrated circuits, or it's like you provided the binaries for the RISC-V architecture?
Well, you provide the binary. It's just like you provide it yourself. Yeah. So you create your own program. You create your own binary. You compile it to a binary.
Okay. Now I got it.
Okay.
Okay, and then we had a comment just about, it sounded a little bit like shards. Maybe you can just comment in the cell phrase, do we have shards, or it comes to a later point, or it doesn't have to do anything with the cell phrase? The phrase.
Right. That's a very good question, which I'm glad you got that was brought up, because the sharding is actually on the layer 1 blockchain. Nervos doesn't have immediate plans to do sharding. But if they wanted to, they're set up directly for that. And that's always a point that's brought up because the microstate architecture that's created by Cell is so inherently sharded. If they wanted to do a sharded system, it makes it very easy. But Nervos believes that using layer 2 is actually a better solution for sharding than sharding, at least on layer 1. And the reason for that is basically because if you look at the sharded networks, there's going to be delays and there's going to be difficulty in moving from shard to shard. So it's kind of the belief of Nervos that what we're going to see end up happening in the future is that most applications are just going to reside on one single shard their entire lifetime, which ultimately doesn't make it too much different than just being on the same shard. And since we're actively trying to push layer 2 here, and that's what a big element of the entire Nervos platform is, it's geared towards layer 2. There's putting all these conventions in place to make layer 2 truly easier to do. It's just simply a different approach. I mean, there are a lot of similarities between actively sharding and using layer 2. I mean, when you talk about moving a piece of state, moving a cell from layer 1 to layer 2, that is very similar to moving a piece of state from shard to shard.
Okay, thanks, Jordan. Then from my side, I got the questions. Maybe Ralf wants to ask also some questions.
Yeah, which RISC-V CPUs are supported actually?
Well, right now, because it's running in a virtual machine, it uses it runs on x86. All of our nodes run on x86. So it uses let's see, I believe the actual standard is the RV64 IMC standard. And so this this is a Linux standard, and there's a number of CPUs out there. I couldn't tell you the ones that are actually fully compatible, but really what you can do is there's a lot of small chips and stuff that are out there right now. I mean, if you just Google for them, you can run on pretty much any of these. You might have to compile it slightly different, but we provide a full toolkit to run this on 86, and soon we're going to actually have ARM as well. So we don't expect you to actually develop on a RISC-V computer. You'll be using your normal computer, and you'll be using the tools just to provide full functionality there. But if you really wanted to, you could take that exact same binary and you could run it on a RISC-V computer as well.
Mm-hmm. Okay, thank you.
Yeah, there's some thoughts that maybe one day, someone who, validation time means money, may have an interest in running the instructions that are being executed on hardware, because I think it's probably an order of magnitude faster. Someone like a miner, whereas if a miner can validate and move on to the next block, say 100 milliseconds faster, then that's money to them, and that we may see dedicated hardware emerge for those kind of reasons. But right now, from the user end, x86 works great for where the network is, and I'll get into it with consensus. It's designed to be kind of like slower decentralized.
All right, so Matt, would you like to take over the presentation? Should I stop sharing here?
Yeah,
okay.
You stop sharing.
Okay.
Okay, just need to get, all right, I need to skip through to get to the appropriate slide. Can you guys see my screen?
Yes, we can.
Yes.
Okay, great. Okay, so now we'll look at consensus. So Nervos is meant to have an adaptive block interval. So the consensus max is meant to maximize block throughput, and it adjusts to network conditions, and I'll get into that mechanism in a second. Also fast block times. So it's hard-coded in the protocol that the block time can fluctuate between 7 to 45 seconds, and it's mostly been toward the lower end of that range. And there's no compromise. The person who designed the consensus algorithm interned at Blockstream and has done a lot of work around alternative POW implementations and reward structures, and the good and the bad of all those. And the idea is that we want to keep the same promises of Nakamoto consensus. We don't want to compromise security or decentralization in the interest of throughput. So first, we'll look at Nakamoto consensus and kind of how we got here. So Nakamoto consensus is permissionless. There's no digital signatures, and you can do it with an unknown number of consensus participants. It's been heavily optimized through the work of Bitcoin core developers, Blockstream, and it's been designed to maximize like every bit of bandwidth in the network. So we think that's a great place to start in terms of building a consensus algorithm for a network. And also has this sleeping beauty property with Nakamoto consensus that a user can go offline for years, and they can come back onto the network and they can validate everything that's happened and all of the proof of work. And there's no need to ever trust what someone is telling you about the sequence of events. The user can always check the thermodynamic and economic security of what brought the network here. And that I think is a fundamental characteristic of Bitcoin and POW networks that have brought blockchains to where they are today. And Bitcoin also has this very elegant security model where demand for BTC will increase the BTC price, which increases the mining reward and then also increases security. And with increased security, now you can do larger transactions, you can store more value on the network, and that increases demand for BTC. Which is scarce, is how you get the increased price. More demand increases the price for the scarce BTC, and the mining reward is also denominated. You have a physical cost for adding a block to the chain. So any attacks would require computational power and time. If someone wants to attack the chain, it's going to require the risk of loss of funds. It's unknown who will mine the next block, and this is security through incentives. If an attacker, has 40% of the hash power and they want to try to reverse a transaction, it's going to cost them a lot to try to take that gamble to reverse it. And this is a great place for place to start. Now, looking at Nervos, we know that there are things about Nakamoto consensus that can't be changed. So without authentication, POW is needed. Unless we want to start introducing groups of keys that we want to trust their signatures on blocks to say that those are valid. In order to have this decentralized network progress forward, we have to do POW. And POW also has to be performed indefinitely because of the sleeping beauty property. If there's ever a time that we stop doing POW, anything that happened since then couldn't really be validated by people who are coming back onto the network. We need to continue putting that economic security on the data that's progressing on the chain. But there are things that we'd like to change about Nakamoto consensus. The first thing is the fixed throughput. So say on Bitcoin today, your throughput is your fixed block size times your fixed block time. And that is a fundamental limit on the network. And there's all sorts of considerations about why these things are in place or how you dial in those parameters. But I think a key thing here is that those parameters are fixed. They're not dynamic. The Bitcoin network has significantly increased in terms of the network capacity and the throughput that it can have over the last few years. And there's no way for Bitcoin to adjust to that, absent a hard fork and the community decided that they want larger blocks or shorter block times. And the second thing is that attackers can modify the chain with less than 50% hash rate. So I'll get into an explanation of selfish mining in a second, but basically Satoshi posited that an attacker would need 51% of hash power to do anything malicious. But over time, we've seen that attackers with lower rates of hash rate can attack, not necessarily attack the consensus process, but can game it in a way that they should not be able to do with less than 50% of hash power. And I think that this is a good time to ask, why not POS? So in researching the consensus algorithms and how to secure Nervos, the team has found that new assumptions in proof of stake mean new attacks. And checkpoints equal trust. If we have a checkpoint every 50 blocks, any user who comes onto the network after those 50 blocks is not able to really verify what has gone into that authentication. They just have to trust that those users that signed those blocks were acting in accordance with the protocol. And the network must also be synchronous. So in order to trust what's happening, I need to continue validating throughout this whole time. I can't just kind of come onto the network later. And that really kind of jeopardizes the sleeping beauty property, which I think is very important for how blockchains got here. Essential to that structure of what is a public blockchain. So with Nervos, we've gone from Nakamoto consensus to Nakamoto consensus max, and I'll get into now how that is accomplished. So the first thing is eliminating the bottleneck in transaction propagation. There is this question around why can't we just make the blocks bigger, or what are the fundamental things in the operation of these networks that stop us from making bigger blocks or making the chain faster. And the first thing is transaction propagation. So in Bitcoin, if a miner finds a block, they'll propagate that block to their peers, who will propagate it to their peers. But inside this block, you have this transaction root. Now, if the other miners in the network have all of the transactions that are contained in this transaction root, that's great. They can then validate the block and they can continue mining. But if those transactions have not been propagated throughout the entire network, the miners who receive this block need to wait until they receive all of the transactions that went into this block in order to validate the block and mine the next one. This can slow down the progression of the network. So Nervos makes a modification to transaction processing, and it happens through a two-step propose and commit process. So the first step is a transaction proposal. So there's a proposal root in the header of the block, and that proposal zone can contain invalid transactions or double spends, valid transactions. It doesn't really matter. The transactions that are in this zone don't need to be valid. They just need to get into the chain in order to be valid later. So miners don't have to validate the transactions that are being proposed, but they will know what transactions they should be receiving. So in this interim, multiple blocks are coming in. All of the miners are then synchronizing all of the proposed transactions so that when they eventually receive those transaction commitments, they don't have to go out to the network and try to find those transactions. They already have them. And then they can validate the block and they can move forward with mining the next block. And this eliminates a major bottleneck in these networks. Yeah. So all of the all the nodes in the network will have all of these transactions that are trying to be confirmed in a block as soon as the block is received. Second thing is a dynamic adjustment of block time. So here's a picture of the block explorer. And you can see the average block time, at this snapshot was 9.42 seconds. And this block time is retargeted every 4 hours. And how it is calculated is based on the orphan rate of the blockchain. So if we look at a blockchain progressing, we have A, B, C, D, and then down here we have B2. So B and B2 were mined at approximately the same time, but the majority of the network built C on top of B. So B2 is not a valid block in the chain. Now on Nervos, these are referred to as uncle blocks because they're used by the protocol, and blocks that build upon, I guess, later blocks will reference the uncles that they see in the network. And then this is used to target a certain uncle block rate of 2.5%. This has been running for 6 months and it has worked pretty well. Like the uncle block rate has been pretty steady around 2.5%. Now, the reason to control the uncle block rate is we don't want to see miners mining on 3 different blocks or chains at the same time, because we're dividing hash power among 3 different chains then, and that makes it easier for an attacker to create a longer chain than the canonical chain. Now, yeah, I think I covered this, that if these uncle blocks are being referenced in the block header, then the node or the chain itself can calculate how many uncles did we see in the last 4 hours. And if there are too many uncles being produced, the chain will actually increase difficulty to slow down the block time. And if the uncle rate is low, say it's only 1%, then difficulty will actually reduce to increase the block time. And this has allowed Nervos to have very low block times without making compromises in regard to proof of work security. And the third thing we want to do is eliminate the incentive for selfish mining. So to give a description of what selfish mining is, so an attacking miner will find a block and they won't propagate that block out. They'll then start mining the next block. And they'll wait for an honest miner to communicate a block. And because this selfish miner maintains connections with lots of nodes in the network, once they see an honest miner's block, they'll flood the network with the block that they found. And that then orphans off the honest miner's block and is reducing the amount of hash power that the network is seeing. Because that honest miner's, I guess, work is being disregarded, the selfish miners not adhering to the protocol of propagating their block as soon as they find it, the difficulty is actually going to adjust lower than it should be, and the miners are going to receive additional compensation that's attacking miners. So in order to fix this, because we have uncles referenced in the block headers, the difficulty adjustment for Nervos is taking all of these blocks into account. So by including the calculation of uncles and canonical blocks in difficulty adjustment, there's no reason for these selfish miners to do this, because they're not gaming the difficulty adjustment calculation at all. It's still going to be the same whether they try to orphan that block or not. And a user can reliably do selfish mining with less than 50%. I think it's something on the order of 25%. Now, I want to talk about the economic model that's introduced through the proof of work. So we discussed before about this security model of Bitcoin. So ideally, we want to replicate this. I think there's been a decent amount of discussion in the Ethereum ecosystem lately about a lack of value capture from the economic activity that's occurring above it. So, Tether has increased substantially, or Tether usage on Ethereum has increased substantially. And it starts to highlight this concern that people have raised in the community for a long time, but now it's starting to actually come to fruition that ETH is not the main asset, or it's not the only major asset being transacted anymore. And it's starting to beg the question of if Tether volume will eclipse ETH, and maybe it already has. I'm just not thinking about the charts. But if you have your block reward denominated in ETH and you have millions of dollars in Tether flying around in each block, you start to create this incentive for users to double spend these assets on top of these chains. So I think with Nervos, ideally we want to replicate this property where increased asset storage or usage on top of Nervos is increasing the security budget and the security of the network, so that we get this virtuous cycle like this in Bitcoin. And this is done through the CKB, which Jordan touched on before. The native tokens allow a user to store data on chain. They're actually owning this space. And we're talking about small amounts of data. It's not like IPFS, maybe 150 bytes to store tokens. And the CKB issuance also then determines the state size. So I think today, something like 17 billion tokens has been issued. So the max state size could possibly be 17 gigabytes. And one thing that Jordan mentioned, the state rent, and this, I feel the need to make clear because of the way state rent has blown up in the Ethereum community, that it is not a payment that's made or upkeep on contract or something that you have to continually top up if you're occupying more state. Because the users own this state, say these 150 bytes to store tokens, if a user is using those bytes to store data, they're incurring an inflationary cost through one portion of the issuance, and that is how they're paying their rent to the miners, is through inflation that miners receive because users are storing data. So back to the security model. So we want to see this increased miner reward, which increases security. And because Nervos is a multi-asset chain, we're going to see demand to store assets. That is going to be the driver of usage of the platform and what people want to use it for. And because that storing assets requires these CK bytes, and the issuance of CK bytes is finite. There's only so many CK bytes in circulation at a certain time. If demand goes up, that's actually going to increase the value of those CK bytes because they're scarce. And that in turn increases the mining reward because that mining reward is denominated in CK bytes, increasing mining security, and in turn demand to store assets. I think the ability to transact diverse assets in large amounts, I think, is a major draw of smart contract platforms, and that should make Nervos ideal place to store assets. And maybe, do we want to take questions on consensus before I get to the next topic?
Yes, of course. I would like to start, Matt. Maybe there are some easy questions, and there's maybe some questions which needs more detailed explanation or building understanding.
Sure.
I will start with the easy one. How many nodes does the network currently have? I mean, you mentioned this map where you have nodes all over the world. Do we have some numbers ready for us?
Not at the moment. Yeah, we're just getting the node metrics out. And I would say, I think judging on the ecosystem and saying, I would say today, it would be in the hundreds. I think we're still, at an early stage and growing. But the way it's been designed is to allow, like I'm running a node on my, not so great laptop right now.
And I think if you say it's easy to run a node, this also implies that currently in Ethereum you have this big portfolio of nodes like Archive node, then Light node, and so on. In Nervos, all the nodes are the same currently, or is it also planned like to have some kind of a Light node or full node and all these classes?
So I'll get into light clients after this, which is a bit, I would say, I guess a different category from nodes, because. Yeah, I think the archive node thing, I don't know. I think the architecture, like there wouldn't be like an archive node. I think that notion of like intermediate states, I think you need that because of the nature of Ethereum. Because well, I'll get into the differences. Maybe we can go back to archive nodes after I do this section, because I think it'll make more sense.
Yeah, the last question, wait, Ralf, sorry. The last question which I have is about the CK bytes. Did I get it right that I can imagine the CK bytes like the gas in Ethereum, or it's a little bit more different or more complicated than that?
Yeah. So yeah, I wish I had included this in the architecture part, because I think it's important consideration. So on Ethereum, the gas is a bundled metric. So there you have a gas cost of 20K to occupy a storage slot, and then you also have gas of like 3 gas to do an add operation. So your measurements of computation and storage are bundled, and there's no shortage of effort to try to dial in these pricings correctly. But on Nervos, they're 2 separate metrics. The computation can be paid in, the computation is a measure of like how many compute cycles is required to execute this, right? That's just like machine cycles. Yeah. Has nothing to do with the token or anything like that. That's used by the nodes. You only have so many compute cycles in the block. But the transaction fee can be paid in CKB or paid in other tokens. But it's similar to Bitcoin, where you have your input amount, you have your output amount, and whatever the delta is between those two goes to the miner as the transaction fee. It's not bundled up in the cycles thing. It's up to the miner to accept the transaction. But those CKB, like if you own the space, then you can occupy it. And if you want to add 4,000 bytes to that space, it's up to you to provide an appropriate transaction fee to the miners to accept that. But you're not going to pay like 20,000 gas per storage slot. Like that is your space to put the data there.
Okay, I have a recommendation, because I think a lot of people are interested in to see more about this matrix. So later on, please put, or in Twitter, put some links where we can find the additional information. This would be really nice. And now, Ralf, it's on you.
Yeah, I have a question regarding the incentives. If I'm a minor node or a node, what are the incentives, and how can I earn maybe CKB or money?
In terms of running a node, there's no master nodes or anything like that. You mine, you get tokens. There's something called the Nervos DAO long-term holders can lock their tokens in and actually offset that state rent that I talked about before. But there's no way to earn tokens, from running nodes. And as far as I would say the incentives to run a node, to utilize the network, I think that's been the largest reason I've seen that people run nodes is like the desktop wallet. In order to use it, you have to run a node. If you're mining, you have to run a node. If you're an exchange, run a node. And I think the structure of the network has been designed that it is not a major challenge or impediment to run a node. Is required to sync. Are there any more questions, Arno?
I just shortly had an interruption in the internet. I'm sorry. So I think the last 10 seconds I got an interruption. I don't know if someone was doing the DOS on me or something, but I'm back now. Everything is okay. So if Ralf is done with the questions, I think we can continue with the, or maybe Tor Alexander, you have any questions, comments so far?
Not at the moment, and not so important. With the pruning mechanism is interesting, but you can send the information later. No problem.
Okay.
Yeah, I mean, most nodes won't need the history. It works well for bootstrapping the network and sharing that history with other nodes. But I think as the network becomes kind of more robust and decentralized, yeah, most users won't need that history.
Okay, thanks, Matt.
Okay, moving on to architecture. So yeah, I talked before about the bounded state, bounded through issuance. The issuance, I won't get into issuance. It gets too complicated. If anyone wants to know details about the issuance, please let me know in the Q&A after. So the idea with this, we want to lower the full node requirements. We get higher decentralization from a network of nodes. And with the architecture, we'll also want to make it faster to sync from Genesis, so every user can validate what has happened on the chain and not have to trust a checkpoint. And yeah, maybe this starts to introduce how that's accomplished by kind of contrasting how Bitcoin and Ethereum works. So on Ethereum, if a user signs a transaction, that transaction may hit a contract that then hits another contract, that then hits another contract, that then hits another contract, and has an output produced. Now, if you wanted to validate these actions, you would have to run all of these. You'd have to execute this transaction that runs through all these different steps. There'd be no way to validate without actually doing the computation. And that's different from Bitcoin. And that it gets in a little bit to light clients. Yeah, this limited state size and also micro state benefits light clients improvements. So a light client can sync only a partial state, the part of the state that affects them. So I showed before in Ethereum, when you kick off a transaction, that transaction can do whatever it wants. It can go, all over the state and touch any contract it wants. There's no way for a user to know with just simply the transaction, what was the outcome of this transaction? How did it affect state that I care about? Whereas in, if we start with Bitcoin, and I have visuals around this in a second. If I have a certain amount of Bitcoin that then, moves to another user, that then moves to another user, that moves to another user, that is not affected by the other transactions that are going into these blocks. Like those transactions are occurring in isolation from the other transactions. So a user can just only look at a certain set of transactions and disregard the rest of everything else that's going on the blockchain because it doesn't affect it. And this is something that's very important to the way that Nervos has been designed. The microstate also is concise. Because we're not doing all of this computation that is linked between all these different contracts and accounts on the network, it makes it very straightforward to validate the things that are happening. And because we are creating a network that's conducive to light clients, we're lowering the trust requirements. There's no Infura on Nervos today, and there's no plans that I know of to build one, because light clients and a network of full nodes should be able to serve the same purpose without introducing this trust in, an entity, an organization, cloud servers. Like, users should be able to just run their own nodes and validate everything that's happening on the chain. Now, I'll get into some explanation of how this all comes together. So there's two different ways you can do on-chain execution. The first is driven by state. So Jordan mentioned before that on Nervos, all of the transactions contain input and output states. You bring in this piece of data that's on chain, you mark it as invalid, and it transforms into a new piece of data that you're then validating that the state transition function was executed correctly. And that's as far as your logic needs to go there. But then you also have event-driven execution, which transactions contain events that will impact what data is stored on a virtual machine and what the virtual machine is programmed to do. But all the transactions contain is an input to the computation. And then whatever the output of that computation is, the virtual machine will just store. But the transaction does not describe anything about those outputs. Now, state-driven execution is Bitcoin-like, and event-driven is Ethereum. Now, that messed up a little bit there. But with the state-driven execution, a user only needs the transactions in order to keep up with the chain state. They don't need to execute anything else. They only need the transactions that they care about that affects their holdings or their data. And so we'll look at how this shows up in Bitcoin. So we'll say that this user, TX0 affected them. Maybe it spent some of their coins, or they received some coins from it. Somehow they were a party to TX0. Now they can get a Merkle proof that TX0 was included in this block 11, and they can get proofs that block 11 is a valid block block 11 is in the longest chain. But all of this other stuff around, say, block 10, block 12, TX1, TX2, TX3, none of this matters to them. They don't have to worry about it at all. And this creates a very effective way of communicating truth throughout the network without requiring a lot of data or a lot of assumptions or trust in anything. And I showed before, if we're to look at kind of trying to do this on Ethereum, we'll say there's this transaction which kicks off to this contract, and kicks off to this contract, and kicks off to this contract. The only way to know that this particular transaction produced the outcome that it did is by executing. And on Ethereum, I believe there's storage root proofs that full nodes will give to users about, this is the current value of this storage slot at this time. But I think it creates a very different kind of network when users can simply view the blocks and filter out, events that don't matter to them, and see the truth for themselves, rather than having to query full nodes and asking for proofs. It's just a different, in terms of how information is kind of like flooded out into the network, or if it's queried individually. I think it's a very different kind of network. And now on CKB, all state changes are explicit in the transactions. So you have these inputs and outputs that Jordan described. And yeah, a similar thing here, TX0, the user cares about this, but the rest of this stuff they can just kind of throw away. And I think another key advantage of doing things this way is there's a good amount of innovation in the Bitcoin community around how you can increase the, I guess, privacy of this kind of thing, and also, I guess, increase the throughput or effectiveness of creating this kind of structure. And with the architecture of CKB, all of that, research and insight and learnings, all of that gets to be kind of applied to this situation. And yeah, a bit of a different subject, I guess I'll hop around here. with this structure, transactions are being generated on this, I guess, second layer or like off chain. And then they're just being taken to the chain for validation. So this lends itself well to a two-layered network. If let's say they'll take the example of a DEX of if there's some kind of coordination required off chain to create the DEX transaction, like some interaction between users that then gets moved to the chain, that starts to lend itself more to a second layer network rather than a DEX that just requires a user to send a transaction to the chain. And I think that there's a whole lot of other questions and challenges that get introduced here. But I think a key point that we want to get across is that the way forward, as far as this project is concerned, is through layer 2. So the more that we are forcing user activity to occur at higher layers off the blockchain, we're getting closer to what those layer 2 solutions look like and what those design patterns are and user interactions are, how we get closer to everyone using layer 2 rather than just abusing the layer 1 blockchain. Here's a little pretty graphic. Yeah, layer 1, layer 2. And yeah, I want to show here how the microstate also supports this layer 1, layer 2 paradigm. So if we look here, we have straightforward, all of these cells are at layer 1. But what if the way that the scripts were structured, say if instead of a lock script that only validated my signature, it validated 2 signatures, and that could then be a payment channel between 2 different parties. So we very quickly can change these cells from being able to be unlocked by a single signature to multiple signatures with time locks and things like that. And all of a sudden, these cells are actually at layer 2 instead of layer 1. And by dividing the state, yeah, I think like Bitcoin has been very kind of conducive to Lightning, and one of the biggest questions I've had watching all of the different payment channel and state channel projects on Ethereum over the years has just been this question of why Ethereum is so much more flexible. Like, why don't we see something like Lightning on Ethereum? And I think part of the challenge comes down to this thing of if instead of well, yeah, we'll just say that this is better because your state is separated. We don't have to worry about security and users' funds kind of being moved between them the way we see with recent DeFi attacks, things like that. If the state is logically separated, and it makes it very easy to move between layers as well. So we'll say, what if Bob wanted to move from layer 1 down to layer 2? He can just process a transaction that conforms to the rules of that layer 2 protocol, and now his funds are back at layer 1. And we've seen, I mentioned before about being able to make use of research in the Bitcoin community. So this was recently posted to the Nervos Talk forum, and it really is an implementation of an idea in I guess Lightning research called L2. Basically a new way of structuring transactions to, I guess, make a better Lightning network or payment channel network. But it requires a new opcode in Bitcoin. So it's a big TBD when users would actually be able to use this. Whereas on Nervos, because it's fully programmable, people can just start to experiment with these things and implement them. And we can also make use of all of this kind of groundbreaking research that's going on across the Bitcoin community. And I guess with that, I will wrap it up. And yeah, thank you all for having us, and thank Jordan for speaking as well. And yeah, take any questions from there.
Matt, I think I will again start, and I really have to thank you for a few, not only like from a Nervos perspective, you also mentioned Ethereum aspects, which you were wondering over the last months, years, how the progress is there and compared it to Nervos. Really big thanks from my side the presentation and also for like like your personal opinion on the situations which happened. In the live chat, I see so far no questions. Maybe I just have also some comments from my side, or maybe it's a mean question, but I just want to ask it. Does, like you said already, you learn, like the Nervos team learns from the experience in Bitcoin and vice versa. So in Nervos, if the developers can play around and experiment, they maybe take something back to the Bitcoin core or to Ethereum core and so on. And do you think this is like with purpose, or it's just a coincidence that this situation is happening?
So I think there are some challenges there. I think so. In that payment channel post that I showed, there are some real questions around, say, like routing in payment channel networks with Lightning, things like that. I think that research can kind of cross over and kind of go back the other way. The thing that I see is that there's a bit of kind of like a standing on the shoulders of giants thing with Nervos, where a lot of these things have just been framed in a different situation based on learnings from previous chains. And I think Bitcoin is just a little too limited to really make use of a lot of these things. And then the architecture of the way data is held on chain is very different with Ethereum and Nervos. So I don't know quite where that comes in. I know with ETH2, because ETH2 substantially changes the way things are architected. There may be also kind of like some areas where research has like that middle of the Venn diagram. But yeah, I would say those opportunities are kind of limited in comparison to the ability of how much the learnings or research that Nervos is able to make use of from the rest.
Okay, and if someone is asking you, is the Nervos network more for B2B, like business to business use cases, or would you say like Nervos is best fitting for a specific industry or branch, or like what could you say about like the positioning and strategy from Nervos? Like how to get in the market? You want to be top 20 coin market cap, or what is like the goal, the mission?
Yeah, I think this is still a bit of a question we struggle with a little bit in terms of positioning. The goal has been to produce like a very flexible blockchain that is very secure and allows developers to kind of have the ability to run wild. And one target market has been developers who may be interested in blockchain but don't want to use Solidity, don't like Solidity, or want, or maybe they like the trust, maybe the trust or things like that from Bitcoin, and then don't kind of like that in the Ethereum community, that a lot of these things are kind of rationalized, that maybe we can compromise on these things. In terms of business, it does seem to suit itself in some ways to more of like a general payment kind of network rather than like the decentralized application DAO kind of thing. Like I think with Ethereum, we've gotten so used to dApps, and with all the ETH killers, also dApps again. And the thing I see with, say, that payment channel construction, that Nervos may look very much like a financial network in a way that Bitcoin looks like, and the smart contract platforms haven't looked so much. I think with layer 2 solutions, you probably do have like financial kind of entities that are operating them. So maybe that's part of it, of the businesses that are targeted are financial technology kind of companies.
Okay.
But there isn't kind of like a direct slant of, say, like the Tron arcade program or something, where it's like Tron is going to fund $100 million worth of games. Like we're not taking that, like, I guess, strong of a hand to say this is where this goes. I think a lot of it right now is like engineering the core functionality and making sure the dev ecosystem is well supported, and like that is the focus. And honestly, because it's so early, there are still some questions around that. Like, well, what is this good for? What is this unique?
I think Jordan wants to add something here.
Right.
Oh,
yeah,
yeah.
I want to add a little bit to that. Like Matt mentioned, we believe that we're still pretty early days into blockchain and trying to find the actual use cases. So when you say what's the biggest differentiator between something like Nervos and something like Ethereum, right now, today, there's not a huge differentiation. We're seeking similar markets. We're kind of going after general use. I think down the line, though, when you try to look further down the line, once we have more adoption throughout the entire world of the platforms, the little differences, the little subtle nuances that are different between the different platforms will start to matter a lot more. At that point, we'll actually see the niches start to form. And for example, like I can give a couple of examples of things that I think will matter much more down the line. For example, the state rent model that Nervos is using is something that Ethereum will have to address at some point. There's open discussion topics in their forums. They're talking about how they're going to address state rent, but there's nothing decided yet. How they decide to implement state rent will definitely change the environment that the current dApp developers are using. It could make certain applications work very well. It could cause other ones to completely fail. Like we really just don't know what's going on with that yet, and that's a decision in the future. So those type of things will change over time, and until we have much more adoption throughout the world, we're not really going to see a strong differentiation.
Okay, Jordan.
Okay.
Thanks. Jetzt now, Ralf.
I have a question. If you can wish, where are the Nervos, or where should be the Nervos network or the CKB blockchain in 2 years?
Where, like, you
Where
just
means
like,
how
like
much-
general like vision for the future, right? That's kind of
Yes.
okay. Jordan, do you care to take that first?
Let's see. I think 2 years from now, we'll probably start to see a lot more layer 2 constructions start to happen. Right now, the main focus for Nervos is layer 1. We're still building out the tooling, and we're still releasing SDKs, and we're still documenting it. I have to admit, I'm doing a bunch of the documentation myself. That's part of my job. Our documentation is terrible. Like there's no way around it. We don't need to BS on that. It's terrible, and we need to improve that. So once we get that all going, and in 2 years we will have that, we'll have a full educational center available for developers to come on board much more easier. And that's probably at that point, we're going to see much more on the layer 2 side. We really believe that that's the future of the scalability, and really the future of all blockchain networks is probably going to be on layer 2. And so I think that's where we're headed and where we're going to be in 2 years.
Mm-hmm.
Yeah, I agree with Jordan's assessment. Yeah, I think with layer 2, I think this notion of a blockchain can start to show up in people's lives in different ways, that it's just not now, because you actually have to interact with the chain and send a transaction. It's just not as simple as like signing a transaction in your browser. And the thing that I can see with Nervos, say, in 2 years, is because of the cryptographic flexibility and the push to really kind of tear through these challenges facing layer 2 solutions, that it will start to allow this notion of trust from a cryptographically secure, economically secure, thermodynamic, whatever data structure to show up in people's lives in new ways. So there's like one topic that has been discussed over time is like the notion of like having a PGP key stored on chain, and a user signs an email with that PGP key, and the user can have a light client within their email that then can check what is the identity of the person I'm receiving this email from. And I think the platform is designed in such a way that it could be lightweight enough and flexible enough to enable use cases we haven't even thought about yet. And I just see that we'll see it show up in hopefully a lot of people's lives in new ways that we haven't really considered that blockchains can be useful today.
Mm-hmm. Okay. Are there some other questions? I see on the chat no additional questions. Thor, do you have questions? Or maybe Matt and Jordan, you have questions to ask to our community?
Best meetup you guys have ever done?
For us?
Yeah.
It depends. You know, before Corona, we had really nice meetups.
Oh yeah, Ralph told me all about them. They sounded so good.
Yeah. So I would say there is no best, but we went to Dresden, which is the capital of Saxony, and there's SAP. This is the big ERP system provider. And
Yeah.
I would say those meetups are really nice because we have a nice building there. It's all glass, fancy wall, and we have nice lights. To this times, the stream was not so perfect. But also the content which we had was really, really edge. So I personally like these meetups, and the online meetups so far. Yeah, we have done it 3 times, so I cannot say which one was the best yet, but yours was definitely enjoyable. And I will see in the YouTube analytics how our community was reflecting it on themselves with the viewing time and so on. Yeah, so it's always interesting for us to have some technical experts like you, and specifically if someone is like in the space for more than 2 or 3 years, it's also more interesting for us because as you maybe noticed already, Ralf is doing the meetups, I don't know, since 3 years, 4 years, or in Germany, Ralf is in the scene with blockchain since, I don't know, 6 years or something. So that's why such people like you two are very interesting for us. Yeah, this I can say.
What are the majority of the meetup members? Like, what are they interested in? What do they work on? Like,
We have, like for myself, I was there as a totally newbie, so I never heard anything of blockchain, but I went there and I found mainly developers. So the first kickoff was on a very technical level. Nevertheless, Ralf and Thorsten at this times, and also Johannes Pfeffer, which is now in the Orga team, they always try to explain all the details in a level that I can understand even as an external person. And I had the feeling in your presentation and also in Jordan's explanations that you try the same. And I would agree on that it's as more as you get in the rabbit hole, as harder it gets to explain people from outside what you think and how you see the world. So in our meetups, we always try to get new people from outside, which are not in the rabbit hole yet, and we adjust a little bit the discussion level in the detail, like to say, we ask them, did you hear about this? Do you know this? We also read the Satoshi white paper once. We have an additional hands-on, so where we have a little bit more time, where we have not this fixed schedule, so the people have more discussion time and so on. So I would say our community and the way how we approach and to build them an understanding in blockchain is definitely a good way. But also we have B2B sometimes, like we have people from companies who are thinking about blockchain adoption in the business cases, and they also sometimes come to us. We have academics sometimes because Ralf also supported a lot of master theses, like so sometimes we also have professors from universities at our meetups, and one, for example, professor for laws and is mainly focusing in governance in the blockchain space. Professor Markus Büch is also one of the Orga members. We all do it in our part-time, so that's why maybe you have the feeling that there is not so much activity. But I would say the quality in our output and the quality in the work which we do is still high, even so if you do it in part-time.
Yeah, and I'm by myself working at Slockit, Slocket is a company who has developed the DAO in 2016. And Christoph Jentsch, he is the creator of the DAO code. You know, I hope you have heard from him. He is also located here in Saxony, and he is a very well-known person in the crypto space. I think so. And we are in our maybe participants area. We have lawyers, we have developers, we have infrastructure people, we have also social scientists and so on. And it's not only technical what we are doing or discussing here in the meetups, also new business models or interesting blockchain-based projects where you need blockchain to solve a technical or a business problem and so on. And so we are looking always for new projects, new technologies, new blockchains, and therefore I'm also calling you, asking you. I have seen you and I have heard first time from something about Nervos on the Ethereum meetup in Berlin. One year before or 18 months before. So yeah, also from my side, thank you so much that you have had the time taken to take part and show us your presentation. And okay, so I think we can then go forward, Arno.
Yeah, Matt or Jordan, can you stop the screen sharing, please? Because then I will readjust the presentation and continue with the.
And may I also answer the question?
Yeah. No, of course.
I run meetups in Stuttgart, in South Germany, the city of Daimler and Bosch and some other, or Porsche also. And we have similar topics. I also had the lawyers of the blockchain, of the Liechtenstein blockchain law. Maybe you heard about, was very good. And this presentation was also interesting. And the guys of my meetup are not so deep in the technical stuff you presented today, but I think it was a good opportunity to explain complex things with simple words. Sometimes some stuff was very technical. For me, it's no problem, but for a lot of members of my meetup, I think it's a hard stuff. But if you don't understand all, it's also okay. You understand a little bit and get the feeling of your blockchain project and also the possibilities. And yeah, I also want to say thank you for your presentation, and I wish you good luck for your work. And maybe we can see us in a future in Germany, and you can make a presentation in lifetime. And I also want to add your meetup. I also joined the meetup in Saxony, and because I was in Weitere at the spring school or autumn school, and the best meetups there was because there was a nice food and a drink.
Yeah. It goes such a long way. Yeah.
Because the university, or we say in German, Hochschule, sponsored these meetups, and it was with nice catering, and it was very nice evening. And Arno was also sometimes there. But Ralf was every time in vacation. He was very seldom there.
I don't know if you have this. I think this sounds like very unique to the U.S., but at the meetups in the U.S., there's always pizza. Pizza is always like the standard meetup food, and you know, there's so many times in my life like eating pizza for dinner 4 nights a week, going to all these meetups. And since Corona started, this is the first time that I thought about like the meetup pizza
Yeah,
and like
where's the pizza? Yeah.
how good it's going to be when someday, who knows how long, but one day the pizza will return. Like that's like I've been trying to like think of how we get things, you know, started again. How do we like get in the habit of these meetups again? But I think it's, at least in the US, it's the pizza. We just bring the pizza and then it'll happen.
Yeah. Okay. So we have only, I think, 10 minutes left. Let me check the agenda. So usually we end the meetups with blockchain projects. Oh, we are already over the time. So nevertheless, the last points are for everyone about blockchain projects. And then we have, of course, a farewell and introduction of the next topics for June. Now it would be July. So sorry again here, a small typo. Ralf, do you want to give an insight about the next month meetup, or
Yeah, I can do it, but I have all these things, mistakes changed before, and you changed the background. Arno, it's unbelievable. No, it's yeah. So I switched to
German. Yeah, we will wrap it up in German because we are already over time, and we don't want to strain it longer.
But I think we'll drop off.
Okay.
Guys, thank you guys so much for having us. This has been great.
Thank you.
Wish you the best with everything you guys are working on. All right, talk soon. Bye-bye.
Ja, die nächsten Themen sind halt, wir wissen noch nicht, ob wir im Juli eventuell wieder zusammenkommen können, sprich, oder ob wir online weitermachen. Ich würde erstmal auf online orientieren. Wir werden das natürlich nochmal im Orga-Team besprechen. Meine Idee oder Vorschlag wäre für eines der nächsten Meetups mal ein Spezial-Meetup zu ausschließlich Identity zu machen. Digital Identities basierend auf dem Standard Self-Sovereign Identity oder Self-Sovereign Identity. Es arbeitet da zurzeit eine Arbeitsgruppe des W3C-Konsortium zusammen mit dem DIF, das ist die Decentralized Identity Foundation. Ich selber arbeite in einer dieser Standardisierungsgruppen, die sich um die Standardisierung des Identity-Protokolls versuchen weltweit mit. Und ich könnte mir vorstellen, dass es Sinn macht, eventuell den Rufen Heck, das ist ein Deutscher, der in New York lebt, von Newport Konsensus zu gewinnen, vielleicht einen Vortrag zu halten online. Ob das schon zum nächsten Mal im Juli möglich wäre, kann ich nicht sagen. Ich habe das nicht präpariert. Zweite Idee wäre, es läuft ja im Identity Management in Deutschland gerade ein Wettbewerb. Dazu hatten wir im März schon mal informiert über sichere digitale Identitäten. Und da gibt es ein Projekt, das nennt sich Liebe. LISI ist die Abkürzung für Let's Initiate Self-Sovereign Identity. Und ich könnte mir vorstellen, so heißt auch dann ein Konsortium, was dort bieten wird. SSI für Deutschland, den Helge Michael könnte ich versuchen einzuladen. Es besteht auch die Möglichkeit, Carsten Stöcker von Sverity, auch ein deutsches Identity-Startup, vorzustellen, eventuell sogar mal mit einer Diskussionsrunde. Ich könnte mir vorstellen, dass ich die Projektleiterin, Abteilungsleiterin aus dem BMWI, die dieses Secure Digital Identities verantwortet, mit einladen könnte, sofern es online stattfindet. Ja, das ist eine Idee, also ein gekapseltes Identity Meetup. Und sonst im Technischen ist halt jetzt die Frage, eine andere Idee könnte auch mal wieder sein, ein Blockchain oder die Energie Web Foundation einzuladen, also Blockchain und Energy-Projekte mal zu besprechen, vorzustellen. Und aber wie gesagt, dann bräuchte man mal irgendwie so ein bisschen Input. Ihr könnt euch ja gerne auch auf den Meetup oder Slack-Kanälen, wo wir das PC Saxony, das ist ja gezeigt worden, wo viele auch Mitglied sind, aber das ist ein bisschen ruhig geworden, melden. Gerne auch, wenn ihr jemanden kennt, der einen interessanten Projektvorschlag, Geschäftsvorverhalten oder Geschäftsidee vortragen will, Da gibt es zum Beispiel ein Startup, Memoresa aus Leipzig, das hat die Idee, sozusagen die ganze Nachlassregelung, wenn jemand stirbt, dann muss man ja auf 1000 Ämter rennen, zu digitalisieren und das eventuell auch Blockchain-basiert, inklusive notarielle Beglaubigung von irgendwelchen Dingen, die da wie so ein Testament oder sowas wirken könnten, zu regeln. Dazu gehören auch dann Online-Accounts, die gesperrt werden. Wenn man das alles mal durchdigitalisiert mit digitalen Identitäten, den Stefan Stunzig könnte ich mir vorstellen, dass er mal seine Geschäftsidee vorträgt. Gut, Nachlassregelung ist nicht so wie ein Geburtenregister. Ne? Sex und Blockchain, das hat man auch noch nicht, könnte auch noch eine Idee sein. Wenn jemanden kennt, der da Blockchain und Sex was anbietet, habe ich schon mal gehört, soll es geben. Aber ja, ansonsten sind wir offen für Ideen. Also wie gesagt, ich würde erstmal online orientieren. Der nächste Termin für dieses Meetup wäre der 1. Juli. Das ist der erste Mittwoch im Juli. Und ich würde mal auf online, sagte ich schon, orientieren. Eventuell auch noch mit einem zweiten oder Thorsten oder Thor, du kannst es ja gerne noch mal ergänzen, wie du das Meetup nur fandst. Ob wir vielleicht auch noch mit einem dritten kooperieren oder ja, müssen wir schauen. Das ist aus meiner Sicht die Vorschläge, Ideen, die sich so bei mir zusammengetragen haben. Arno, gibt es da bei euch noch andere?
Alles gut.
Also ich hatte mit dem Oliver Negle mal ein Meetup gehabt zu digitalen Identitäten. Das war auch ziemlich tief, aber zudem habt ihr ja auch Kontakt, notfalls, ne? Aber oder notfalls
Ja.
kann ich ihn auch fragen, wenn er da online mal Lust und Zeit hat. Wobei ich das ehrlich gesagt mit den digitalen Identitäten immer ziemlich skeptisch sehe. Weil das der Schritt für mich in die KIs ist und das ist die letzte Erfindung der Menschheit, wie Stephen Hawkins mal gesagt hatte. Aber da werden wir eh nicht uns nicht rausschleichen können. Die Frage ist, gestalten wir da mit oder lassen wir uns gestalten? So, und Krypto-Nachfolgeregelung hatte ich ja auch mal im Buch geschrieben, das natürlich dann auch in diese Nachlassgeschichte mit rein zu packen. Wie gehe ich jetzt mit digitalen Sachen um bei der Nachfolgeregelung? Das könnte ich da noch ein bisschen mit beisteuern. Wie gesagt, da habe ich ein Buch veröffentlicht, Bitcoin-Testament. Ansonsten, mein Vorschlag von vorhin war halt, was ich auch spannend finde, ist jetzt ein bisschen außerhalb des Blockchain-Topics, aber immer noch irgendwo im DeFi oder im Geldbereich drin, ist dieses Leistungsabrechnungssystem, also sprich eine Währung ohne Geld. Und das Konzept finde ich eigentlich gut. Und wie gesagt, ich habe da einen bei mir in der Gruppe drin, der das mal vorstellen würde und auch online. Falls da jetzt Interesse bei euch mit besteht, dann könnte ich das auch von mir aus zum 1. Juli versuchen mit zu organisieren. Und ich denke schon, dass er da Interesse hat und den Rest kann ich dann natürlich auch versuchen, da noch beizusteuern. Ich würde es dann über euer Equipment mit laufen lassen und bei mir natürlich auch in der Gruppe mit ankündigen. Ich habe auch gesehen, im Livestream war mindestens einer dabei, zumindest der sich da zu erkennen gegeben hatte aus meiner Gruppe und ein paar andere, denke ich mal, waren auch noch dabei und das ist jetzt auch wieder ein Thema, was jetzt für, sagen wir, Blockchain-Neulinge oder für Leute von außerhalb auch von Interesse ist.
Naja, danke. Wie gesagt, ich hatte noch die Idee, dass ich den Chef der Bundesinnovationsagentur, der Agentur für Sprunginnovationen, angesiedelt in Leipzig, das ist der Rafael Laguna de la Vera, den habe ich angefragt. Diese Agentur ist dazu gedacht, wirklich extremste Sprunginnovationen, sagen wir sowas wie den MP3-Standard oder noch schlimmer die Erfinder des Autos oder die wirklich was Größeres zu bieten können.
LCD-Displays.
Ja, alles so machen, aber er hat dankend abgelehnt, weil er meinte, naja, er kann da nicht beitragen, wir sind Blockchain zu spezifisch für ihn.
Aber er könnte mal ein bisschen über seine Arbeit quasi berichten, was er so
Das war meine Idee, dass er generell, was die Aufgabe ist und auf welche Art und Weise er nach Sprunginnovationen sucht, die findet oder finden gedenkt. Das soll ja auch mit bis zu 500 Millionen ausgestattet werden, Startups gegründet werden und. Der wird mir schon noch mal über den Weg laufen, der Bursche. Spätestens, wenn ich mal wieder im Bundestag bei der CDU-CSU-Fraktion bin, hat er auch gedacht, gestern war die Vorstellung des Buches Neustart von Thomas Heilmann, den hatte ich ja schon mal im Meetup, der für die Blockchain-Strategie der Bundesregierung wesentliche Einflüsse hat. Da war ich gestern auch mit Jens Spahn dort in so einem Video-Interview eine ganze Weile. Ja, das ist auch Start über Blockchain abbilden, inklusive Voting. Es gibt sehr viele Ideen von 103 Ideen von 63 verschiedenen Politikern und Führern. Hatte ich auch schon mal nochmal die Idee, das vorzustellen, aber müssen wir sehen. Okay.
Also vielleicht kannst du ihn noch mal versuchen anzusprechen, weil ich meine, wenn wir das jetzt als Gemeinschaftsveranstaltung titulieren und bei uns im Raum Stuttgart bin ich natürlich durch Daimler, durch Porsche, durch Bosch und noch ein paar andere Mittelständler ziemlich ingenieurlastig. Und ich habe noch ein zweites Meetup, InnoRapt, wo es jetzt eher so um Blockchain-Technik geht, ohne Finanzzeug, wobei ich immer der Meinung bin, dass man es nicht richtig trennen kann oder sollte. Und auch noch einen Zugriff über ein IoT-Meetup, sodass ich da auch einen recht großen Verteiler habe, um solche Sachen Richtung Innovation auch mit zu verteilen und Leute anzusprechen. Also ich denke mal, dass man vielleicht über die Geschichte ein bisschen leichter bekommen kann.
Ich will jetzt eure Diskussion nicht abbrechen. Ihr dürft ja
Nee,
gerne weiter im Zoom bleiben. Ich muss nur den Stream beenden. Also ich bedanke mich nochmal für alle, die zugeschaut haben. Und ja, wir sehen uns dann, wie der Ralf gesagt hat, 1. Juli. In dem Sinne, tschüss.
Tschüss.
Ja, macht's gut. Bis zum nächsten Mal und danke fürs Teilnehmen.